Alright, so now we're going to be looking at some Suvat equations. Now these equations are very useful and come up a lot in exams because they're used to help us determine or work out certain velocity values, displacement values of a certain particle in motion. First things first, these equations, there's 5 of them, and they're only really applicable when the acceleration is constant. Okay, so when the acceleration is constant, then we can use these equations. If they're not constant, then we can't use any of these equations. We're going to be using a different method, which we'll look at in a later video. So first things first, as I said, there's 5 of these equations, and they are in the formula book here, so you don't have to memorize them, but it's very good. I would recommend you guys memorizing them because you want to bring them out straight away when you're dealing with questions. You don't want to be like flicking through the formula book, right? So first things first, they're called Suvat for a reason because there's 5 letters which we need to be aware of. S, first things first, represents displacement. So this is the distance or the difference between the starting point and the finishing point. U is the initial velocity, i.e. the velocity it starts off with. V is the final one, velocity which it finishes. A, acceleration. T is time. So that's why it's called Suvat equations. And there are a series of 5 here. Right, so the common ones which are most likely used are this one here, because this equation here has no t constant in there. So whenever we're not given a time variable, we use this equation quite often. Also, this one here is also used quite often as well to work out the displacement of a certain particle. This fourth one here is not used as often because it's just a variation of the third one. But where, as you can see, it's ut, this is vt, and this is plus and minus. So this is very similar equations. So it's not used as often, but you just need to be aware of all of these 5 equations. Okay, so we're going to be looking at in this video when the particle is moving in a horizontal line first, and we're going to be looking at vertical in the next video. So a particle travels with a uniform deceleration 2 meters per second squared in a horizontal line. The points A and B lie on the line, and AB is 32 meters. At time t is 0, the particle passes through A with velocity 12 in the AB direction. Find the values of t when the particle is at B. Okay, so first things first, what I need to do, what you guys should always be doing is working out or listing what you know out of the Suvat values. Okay, so write a list of Suvat and then right next to what you do know. Okay, so we know that AB is 32 meters, so A to S will be 32. It's a uniform deceleration of 2 meters per second, right? Deceleration is the opposite of acceleration, so for A we have to write as -2, not +2. At time t is 0, the particle passes through A with velocity 12. So t is 0 means it's the initial time, so that means it gives us an initial velocity, so u will be 12. And we don't really know anything other than that, so we know 3 values, okay? So for A, it says find the value of t when the particle is at B, so we try and find this one here. So now we know S, U, and A, we're trying to find t, okay? So what you need to do is think of an equation, the 5 equations, right? And see which one equation we're going to be using. In this case, we're going to be using S is ut plus half at squared. So we're going to have 32 is equal to 12t plus half times minus 2t squared. 32 is equal to 12t minus t squared minus 12t plus 32 is equal to 0, which I can now factorize. So you should get t minus 8, t minus 4 is equal to 0. So therefore t is going to be 4 and 8 when it's at B. Okay, so it's going to be 2 times when it's going to be at B. Part B. Find the velocity of the particle for each of these values. Okay, so we know t is, once again, let's list them all out. We're trying to find this v here, right? So we know t is 4 and 8. So I can use a very simple equation, v is u plus 8t. So t is 4, just plugging it in. V is going to be 12 plus minus 2 times 4, which will give me 4 meters per second. And when t is 8, plugging that in as well, v is going to be 12 plus minus 2 times 8, which will give me -4 meters per second. Okay, so they have the same speed value, it's just that the direction is opposite or different directions, so they have a different velocity value. Let's try another question. So 2 particles P and Q are moving along the same straight horizontal line with a constant acceleration 2 and 3 meters per second respectively. At time t is 0, P passes through point A with speed 4. 1 second later, Q passes through A with speed 3, moving in the same direction. Write an expression for the displacements of P and Q from A in terms of t. Okay, so first things first, we have 2 different particles, so we need to create 2 different Suvat equations. So let's look at each one separately. So for P, once again, first things first, I want you guys to do is always list out what you do know out of the Suvat values. So we know the acceleration, it's 2 meters per second for particle P, so this is going to be 2 here. At time t is 0, P passes through point A with speed 4, so that means it's the initial velocity, that's going to be 4 here. And then it's going to be at certain time t, so let's call this time t, and let's just call this displacement sp for P. Right, so we can use an equation. Let's use the S is ut plus half at squared again. So we're going to have sp is equal to 4t plus half times 2 times t squared. Simplifying that a bit, SP is 4t plus t squared. Okay, so that's the displacement equation for particle P. Let's look at Q, so for Q separately. Same thing, list out what you do know out of the Suvak values. S, we'll call it SQ for particle Q. It says for Q, is displacement or acceleration is 3.6, so this A is 3.6. Now, 1 second later, Q passes through A with speed 3. So that means the initial velocity is still 3, but for this time, it's 1 second later, right? So P has traveled off first, and then Q is going to travel a second later. So that means that for the time value, it's no longer going to be T, it's going to be T minus 1, okay? So it's not going to be T, it's going to be T minus 1. Once we do this, then we can use the same equations to create a displacement equation for Q. So it's 3 times T minus 1 plus half times 3.6 times T minus 1 squared, like this. And so we have the two equations for P and for Q. Right, B, find the value of T when the particles meet. Now if they're going to meet, it means that the displacement is going to be the same, right? So we've got two equations here. So what I can do now is just equate the two equations together and then work out or solve for T. Like this, like so, okay? And so therefore, hopefully, if you work this out, we'll get 0 is equal to, you'll get a quadratic equation again, 23t minus 6, which I can factorize 4t plus 1, t minus 6. So t is negative 1 over 4, or 6. And the important point here is we worked at the values when they are the same displacement, right? But we worked at the values of time. Importantly, you know that time can't be a negative value, so the only time that they're actually going to meet is when time is 6. When t is minus 1 over 4, that is no longer a solution. C, find the distance of A from the point where the particles meet. Okay, so that means that we've worked out when t is 6, so what I can do now is just plug 6 into either equation. I can plug it into this one here, or I can plug it into this one here, because you know that they're going to be the same displacement away. And if you do, you should get a value of 60 meters. Let's just try one final one. So a car traveling on a straight road slows down with constant deceleration. Deceleration means the acceleration value will be negative. The car passes a road sign with velocity 40 km per hour and a post box with velocity 24 km per hour. The distance between the road sign and the post box is 240 meters. Find in meters per second the deceleration of the car. Okay, so first things first, as we did before, we list out what we know out of the Suvak values. So S is the distance between them, so that's going to be 240 meters. Now, as you can see, the initial velocity at the road sign is 40 km per hour. Importantly, we have to always change these values into meters per second. So we change this 40 km per hour into meters per second, and that's going to be 100 over 9 meters per second. Same thing for this 24 km per hour, we also need to change into meters per second, and that's going to give us 20 over 3 meters per second, like this. So the initial value now for U is 100 over 9, and the final value is 20 over 3, and we're trying to find this acceleration value here. We don't need to know time because we're trying to find acceleration, so I can use the equation v squared is u squared plus 2as. So we're going to have 20 over 3 squared is equal to 100 over 9 squared plus 2 times a times 240, and a you will get a value of minus 0.16 meters per second squared. So as you can see, as long as you list out the initial Suvak values that you're given, then and choose the right equation, then you can work out all these different questions.